Hello student, this is your chemistry teacher. Today we are going to discuss the second chapter of science, that is the acid, base and salt. So let's get started. So first of all I'll give you a short introduction of what is acid and what is base, some chemical properties, some general properties of acid and base. So first of all, acid. Let's start with acid. Acids have some general properties like acids are sour in taste, number one. Number two, generally acids are either exist as solid state or exist as liquid state. If I give you example such as oxalic acid exists as solid state, acetic acid exists as liquid state. Okay, so acids are generally the substances which are sour in taste and exist as either in solid state or in liquid state. Moreover, the third general property of acid is it can change the color of a litmus paper from blue to red. If you put a blue litmus paper in an acid solution or in an acid, the color of the litmus paper will be changed to red, right? The fourth property, that is the that you could say that it is the universal property of acid, or it is the main property of acid, that it gives proton, it gives H plus in solution. In an acid solution, every acid gives H plus or proton. So these are some general properties of acid. Now we are going to discuss the general properties of base. So what are the general properties of base? First of all, bases are bitter in taste. Secondly, like acid, they exist in solid and liquid state. If I give you example, sodium hydroxide is a base, right? And it exists as solid state. Ammonium hydroxide is commonly, we observe ammonium hydroxide in the liquid form in laboratory, right? So ammonium hydroxide is also a base that exists in liquid state. Moreover, it can change the color of the litmus paper from red to blue, just opposite of acid. In case of acid, we observed what thing? We observed that acids are changing the color of the litmus paper from blue to red. But in case of bases are changing the color of the litmus paper from red to blue. And base usually gives OH minus, that is called hydroxyl ion. Sorry, this I have written here as proton. It would be hydroxyl ion. So base will give hydroxyl ion when it is present in solution, or in liquid state or in solution state it gives hydroxyl ion, OH minus. Okay, and in this way we can identify the acid and base. Now the acids are classified on the basis of their source into two categories. First of all, inorganic acids. These are the acids which are obtained mainly from minerals of earth. Like if we give you example, like hydrochloric acid HCl, sulfuric acid H2SO4, and the nitric acid HNO3. The chlorine, sulfur, nitrogen, these are the these are the elements that are formed in mineral, that are found in mineral form, right? So these are the acids whose main constituent, or whose central atom, or whose atoms or elements are found in minerals of earth. That's why they are called inorganic acids, or you can say they are called mineral acid. Whereas in case of organic acids, as organic acids are those acids which are obtained from plants and animal materials, like acetic acid, lactic acid, malic acid. These are all organic acids. Another important property of organic acid is organic acid always contain carbon atom. In case of inorganic acid, you would never find a carbon atom in the formula. As you can see over here, that HCl, H2SO4, HNO3 doesn't contain any, they do not contain any carbon atom. But in case of organic acids, as they are obtained from the plants and animals, and plants and animals are uh, the main structure of plants and animals are carbon structure, right? Carbon skeleton, right? So that's why the acids which are mainly called organic acids, they contain carbon as the element, as one of the element, right? And examples are acetic acid, lactic acid, and malic acid. Now let's move on to the new topic, that is called indicator. And what is indicator and what are their types? So first of all, we have to know what is indicator. Indicators are the substances that indicate whether a substance is acidic or basic by changing its color or by changing its odor. Okay, these are the substances that can indicate the presence of a acid or the presence of a base in a solution by changing its color or by changing its order. Indicators will change its color or change its order to indicate whether acid is present or a base is present in the solution. So the indicators are mainly classified into three categories. First of all, common indicator. These are the indicators that can that indicate the presence of acid or base by changing color. Okay, if I give you example like methyl orange is a common indicator that is usually we use this indicator in laboratory. Okay, and we see that in this methyl orange indicator shows the red color in acid solution and yellow color in basic solution. Moreover, phenolphthalein is a very popular indicator, right? So this phenolphthalein indicator is colorless in acidic solution and pink used to show the pink color in basic solution. So these are some common indicators like methyl orange and phenolphthalein. Now we have to know about a new category of indicator that is called olfactory indicator. Olfactory, as from the name itself, it says you the function. Olfactory indicators are those indicators that usually indicate the presence of acid or base in a solution by changing its order. So if I give you example like onion is a olfactory indicator. Okay, in if in NaOH solution, if I put onion, the smell of an onion would be vanished in case of in acidic solution. Sorry, in basic solution like NaOH solution. If you put some onion in NaOH solution or in NaOH, it would the odor of the onion would be vanished. But if we put onion in acid solution or in an acid, then the odor still persists in that system, right? So onion is one kind of indicator that can indicate the presence of acid or base by changing its color, sorry, by changing its order. Like onion, the other examples of olfactory indicators are vanilla and clove oil. Okay, now natural indicator. What are natural indicators? Natural indicators are basically the indicators which can indicate the presence of acid or base by changing its color. Okay, but here it is slightly different from common indicator. Like common indicators could be made in lab, that means they could be synthesized, right? But natural indicators are obtained from natural resources, right? If I give you example like red cabbage is a natural indicator, right? Onion is also a natural indicator and also a olfactory indicator. Onion is a natural indicator. You would probably see that suppose we sometimes we during taking food we used to get some onion stain in our fresh clothes, right? So whenever we put that cloth in for washing, then we used to observe that the color of the onion stain is being changed, right? Why the color of the onion stain is changing? Because whenever I put the onion stain cloths into a solution which contains some surfactants or which contains some washing material, then in the presence of that washing material the color of the onion stain would get changed, right? And because onion is a natural indicator, it can change its color in alkali solutions or in basic solutions, because the washing powder that we use to wash our clothes usually contain basic substance. So in the presence of that basic substance, onion stains or onions changes its color, and we used to observe that very often, right, in our day-to-day life. So onion is also a natural indicator. Now let's move on to the reactions of acids and bases. So first of all, the most popular reaction by means of which we could identify acid very easily, acids and bases react with metal to give salt and hydrogen. As you can see over here that zinc is a metal, right? It is reacting with an acid to give you a salt, zinc sulfate, and with the liberation of hydrogen. Moreover, zinc can react with NaOH, sodium hydroxide, to give you the salt sodium zincate, Na2ZnO2, with the liberation of hydrogen. Again, acids generally react with metal carbonates to give salt and water with the evolution of carbon dioxide. Sodium carbonate, if I give you example, sodium carbonate is a carbonate salt that reacts with acid like hydrochloric acid, and it would give you a salt NaCl with the liberation of water, and carbon dioxide gas will be evolved from the uh, test tube. So this is the reaction of acid with the carbonate salt, metal carbonate like sodium carbonate. Now if we use to make a reaction like sodium bicarbonate with hydrochloric acid, then obviously a salt will be produced, that is the sodium chloride, and water will be eliminated, and from the reaction carbon dioxide will be eliminated. So these are the reactions of metal, reactions of acid with metal. In this way they react to give you the products. Now the most popular reaction between acids and base that used to occur, that we used to execute in lab every time, that is the neutralization reaction. The neutralization reaction is basically the neutralization of acid by base. We know that acidic substance are show acidic property due to the proton or due to H plus, and basic substance show basic properties due to OH minus or hydroxyl ion, that we have already discussed in the first slide, right? So basically when we make a reaction between HCl and NaOH, then they would neutralize each other and give you a salt give you a salt with the liberation of water. So basically the effect of H plus, this H plus will be neutralized by the effect of OH minus, and they would combine, H plus and OH minus would combine to give you water with the liberation of the salt NaCl, that you can see over here. Now if we make a reaction where acid is reacting with metallic and non-metallic oxide, then what is going to happen? Now let's discuss this. Suppose cuprous oxide, it is a metallic oxide, as you can see that copper is a metal, right? So copper oxide would be obviously a metallic oxide. So this metallic oxide would react with hydrochloric acid to give you a salt cuprous chloride CuCl2 with the liberation of water. Okay, so acid reacts with this metallic oxide to give you salt and water. Similarly, bases react with non-metallic oxide to give you salt and water. If I give you example like calcium hydroxide is a base, CaOH whole 2. It contains OH minus, it can give you OH minus in solution, so it is a base. So calcium hydroxide, this calcium hydroxide would combine with carbon dioxide, that is a non-metallic oxide. It's very important to observe this thing because carbon is a non-metal, so carbon dioxide would be a non-metallic oxide, right? So calcium hydroxide, that is a base that would combine with carbon dioxide, that is a non-metallic oxide, to give you a salt calcium carbonate with the liberation of water, just like the previous reaction. Base, just like the previous reaction, bases would react with non-metallic oxide to give you salt and water. So these are the reactions of acids and bases with metallic and non-metallic oxide. Now we will discuss about the ionization of acids and bases and the concept of pH. So first of all, acids and bases are the substance which in water dissociate to give you H plus and OH minus in solution. As I have already discussed in the first slide, that acids are the substances that used to give H plus or proton, and bases are the substances that used to give OH minus or hydroxyl ion in solution. And by the property of this, we could easily identify the presence of acid or base in a solution, right? So if I give you a example like hydrochloric acid, HCl in water, it would decompose into H plus and Cl minus. So this H plus, that is called, this is called proton, that is liberated from HCl, so HCl is acid, right? So one thing is very important to observe here, that H plus cannot remain in solution alone. It would combine with water to give you H3O plus, that is called hydronium ion. This H3O plus, H plus has no existence in solution. H plus would always combine with water to give you hydronium ion or H3O plus. Okay, now this hydronium ion would indicate us, yes, this HCl is an acid, right? Now in case of NaOH, sodium hydroxide, it is going to give this OH minus hydroxyl ion in water, in presence of water. It would dissociate into Na plus and OH minus, so it is giving NaOH is giving mainly hydroxyl ion, so NaOH is a base. Now Now we are going to discuss the concept of pH. So this is a very important topic. So first of all, what is pH? pH is the negative logarithm of concentration of hydrogen ion expressed in moles per liter. Okay, the mathematical form of pH is pH equals to minus log of concentration of H plus or proton that is present in a solution. So first of all, what is log? Log is a mathematical function just like x square, x cube. Log is a mathematical function. If I take a negative log of a value, which value? The value is the concentration of proton or concentration of H plus that is expressed in moles per liter. That means if your solution contain 4 moles of H plus in a, 1 liter solution, acidic solution, then the concentration of H plus would be 4, right? Then you have to take you have to write pH equals to minus log of 4. Okay, that would give you the value of pH. So first of all, what is the need of calculating this pH value? Why would we calculate this pH value? What is the need? The need is the pH is a indicator, or pH is a parameter that gives us an idea about the relative strength of acid and base in a solution. Suppose in your solution there is a acid present, but you don't know how strong the acid is or how strong the base is. So the concept of pH or the value of pH would give you the idea how strong your acid is or how strong your base is. by uh, by which way? By the way that this pH scale, the pH would give it is a there is a scale that is composed of 14 the values from 1 to 14, where each value indicates a pH value, and these values give you an idea about the relative strength of acid or base. Suppose if your acid if your solution is neutral solution where concentration of H plus will be has been neutralized by concentration of OH minus, then your solution would give you or would show you the pH value 7. Okay, a pure water has pH value 7, right? Pure water is neutral. But if your solution, or if your solution system contains an acid, then the value will be less than 7. The value of pH will be less than 7. Okay, it could be 1, it could be 2, it could be any value that will be less than 7. This will be the pH value. Okay, so pH value 1 to 6 would give you information about that your solution is acidic, and 8 to 14 means your solution is basic in nature. That means if your solution is acidic, the pH value would be ranging from 1 to 6, and you could have an idea that concentration of H plus is much greater than concentration of OH minus. Okay, and in case of basic solution where the pH value would be ranging from 8 to 14, then you could have an idea that your solution must contain concentration of OH minus far more higher than concentration of H plus. So concentration of H plus greater than concentration of OH minus means acidic, and the reverse is basic. And if the pH value is 7, then it is neutral. Okay, so here there are some examples where you could see some substances that we use daily uh, having a particular pH, such as the fruits, mainly apple juice, tomato juice, lemon juice. These all have acidic pH. And egg, baking soda, hand soap, ammonia solution, bleach, concentrated solution of alkalis, those systems would have pH value in the basic range 8 to 14. And these are the colors that they used to show in litmus paper or in an indicator. Okay, so now let's move on to the importance of this pH in our everyday life. Okay, so first of all, pH is one of those factor that is uniformly present in all subjects, in biology, biological system, in biological studies, in chemistry, chemical studies. So pH is the concept of pH is in everywhere, whether it is a reaction, whether it is a biological process that occurs in our body. Everywhere you would feel the presence of the concept of pH, right? So as for example, if I give you that our body works within a narrow range of pH 7 to 7.8, because our the blood of present that is present in our body is actually a basic solution of pH, slightly basic solution of pH, that has a pH 7 to 7.8. Our the blood pH is constant in this range 7 to 7.8. Okay. Now we used to heard a term acid rain, right? So acid rain is the rain that has a pH. If you calculate the pH of acid rain, that would be in the range almost 5.6. So when acid rain occurs, the rain water used to mix with the river water, right? So in the river water, when it mixes up with the river water, the pH of the river water would fall down, right? And if the pH of the river water falls down, then the animal the species that are present in that aquatic world, like fishes, they would feel a difficulty to survive on that pH, on that lower acidic pH, right? They cannot survive. They can survive only a particular range of pH of river water. But if for river water, if river water is mixed with acid rain, then the pH of that river water would fall down, and the survival of aquatic animals in those environment would be very difficult. Okay. Moreover, our stomach always produces HCl, hydrochloric acid, that used to help us in digestion of food. So again, whenever we used to suffer from acidity, we used to take medicine, right? So those medicines are called antacids, right? So those antacids are nothing but the basic substances. They contain some basic substances which can neutralize the effect of the acidity or effect of the acid that is produced in excess in your body, and by means of which you would get relief uh, of that suffering by taking antacids. So antacids basically are the basic substances that used to neutralize that actually neutralizes the effect of acidity or the effect of acid that is produced in excess in your body. Moreover, the mouth of in our mouth, the tooth are they are mainly the calcium phosphate, and they actually starts to decay when the pH of our mouth falls below the value 5.5. That means if sometimes we used to feel some acidity, right? So they, in that case, mouth pH of our mouth falls down, falls down from the value 5.5. In that case, our tooth may decay, right? Because our tooth are made of some substances like calcium phosphate that is a basic substance that used to react with the acid of our mouth when the pH of the mouth of our mouth falls below 5.5. So this is in that case, we what we do we have to what we should do, we should have to use toothpaste in a proper manner, right? So toothpaste contains basically the basic substances that used to neutralize the excess acid that is produced in your mouth, and that can causes some tooth decay. So toothpaste we used to fight with that or used to react with that acidic substances and neutralize the presence of excess acid in your mouth. Okay, so these are some applications, or these are some importance of pH in our everyday life. Okay. Now we would discuss about some salts and their solution, and would study what is the pH of the solution. Suppose if I take a salt like NaCl and Na2SO4. NaCl is called sodium chloride, Na2SO4 is called sodium sulfate. So sodium chloride is a salt that is produced by combination of two substances. One is HCl, hydrochloric acid, another is sodium hydroxide. If we combine these two substances, we can get NaCl, right? So this NaCl solution, if we take, then obviously in the solution NaOH and HCl both would be present, and NaOH and HCl both are strong acid and strong base. So strong acid would completely neutralize the strong base, and there would be no excess acid, there would be no excess base. So pH of the salt solution would be 7. Similarly, in case of sodium sulfate, that is made of sodium hydroxide NaOH and sulfuric acid H2SO4. So both these acids and bases are strong acids and strong base, so they would neutralize one another, and the pH of that solution containing sodium sulfate would be 7. Now let's move on to the second salt. If I take a salt like ammonium chloride NH4Cl, that can be made of ammonium hydroxide and hydrochloric acid. So if I take NH4Cl salt in water, then it would give you NH4OH and HCl, and NH4OH, ammonium hydroxide, is a weak base, but HCl, this hydrochloric acid, is a strong acid. So strong acid would completely neutralize the weak base, right? And there would be excess of acid because it is strong acid now. So this strong acid would neutralize completely this weak acid, weak base, and and after neutralization there will be still some acid molecules present in your system, and that's why due to the presence of that excess molecules of acid, the pH of the solution would be less than 7, right? Now if we take a base, if we take a third salt like sodium carbonate Na2CO3, that is made of sodium hydroxide and carbonic acid, if we combine these two substances, we can get the salt Na2CO3. We have already learned that if we mix one acid and one base, then we can get some salt, right, with the liberation of water. So if I mix these two acid and if I mix this acid and base, we could get the Na2CO3 salt. Now this Na2CO3 salt, if I take in water, then it would give you NaOH and H2CO3. NaOH, sodium hydroxide, is a strong base, and whereas in case of whereas this H2CO3, carbonic acid, is a weak acid. So this strong base would completely neutralize the weak acid, and after neutralization there will be still some NaOH molecules that would be present in excess in the solution. So in your solution there would be excess of NaOH molecules present in your system. So due to the presence of this excess of NaOH molecules, after the neutralization of carbonic acid, due to the presence of this excess NaOH molecules, the pH would be greater than 7. So salt of strong acid and strong base, pH will be 7. Salt of strong acid and weak base, pH will be less than 7. And salt of weak acid and strong base, pH will be greater than 7. So these are the values of pH of some salt solution. Now so we are going to discuss some important compounds of these some important compounds where we would discuss the preparation of those compounds and some uses of those compounds. So first of all, let's get started with common salt. So what is common salt? Common salt is basically the sodium chloride, that is the chemical name of common salt, sodium chloride, NaCl, and it is generally prepared by the neutralization reaction of base NaOH, sodium hydroxide, and acid, hydrochloric acid. If they combine, they would give you a salt NaCl with the liberation of water. Moreover, the sea water that contains that is salty, right? And this sea water is nothing but it is the solution of salt that is present in 2.7 to 2.9% in the sea water. So 2.7 to 2.9% of NaCl solution is the sea water, right? Now we have to move on to the next topic, that is sodium hydroxide. So what is sodium hydroxide? Sodium hydroxide is basically it is a base, right? So how is it prepared? It is prepared by passing electricity in a NaCl solution, and we can get sodium hydroxide, hydrogen and chlorine as the products. Okay, now you can see over here that here electrolysis is made, electricity is passed in a solution. Which solution? Brine solution. Brine solution means sodium chloride solution. So in this solution sodium chloride is present, and it is anode, positively charged anode electrode, and it is negatively charged cathode electrode. So if we pass electricity, then what would happen? Then the Cl minus, that is negatively charged, that would go for the anode, that would go towards the anode, and in the anode chlorine gas, this chlorine gas would be produced. Now in case of cathode side, H plus, that is present in in water, H plus will go to the cathode side, will go to the cathode side and hydrogen gas will be eliminated, as you can, as I have indicated in this diagram. Hydrogen gas would be eliminated from the cathode and chlorine gas would be eliminated from the cathode. Now the sodium hydroxide so formed in this reaction, that would be produced in the cathode side. Okay, so in this way sodium hydroxide is produced by uh, following this process. Now this process of production of sodium hydroxide is called chloroalkali process. Why is it called chloroalkali process? Because the term chlor comes from chlorine that is produced in the cathode, and the alkali, that sodium hydroxide alkali, that is for sodium hydroxide. Sodium hydroxide is a base or alkali that is produced in the cathode, right? For this reason it is called chloroalkali process. Okay, and the sodium hydroxide that is so formed in this reaction is also called caustic soda, right? Now let's move on to the production and uses of some important compounds, like first of all baking soda. Sodium bicarbonate is the formula of baking soda. In laboratory, baking soda is prepared by treating a cold concentrated solution of sodium chloride with ammonia and carbon dioxide. If we treat a cold NaCl solution with ammonia and carbon dioxide, we could get sodium bicarbonate as the major product with the liberation of ammonium chloride. Now this sodium bicarbonate that is formed in this process, if we heat this sodium bicarbonate, then obviously sodium bicarbonate will give you the carbon dioxide gas, right? So sodium bicarbonate, if we heat, it would give you sodium carbonate Na2CO3 with the liberation of water, and carbon dioxide would be liberated, right? And what are the uses of this baking soda? Baking soda is used as antacid to treat acidity in stomach, or the antacid that you use to take for cure for the cure of acid from for the cure from acidity, that is actually that contains actually the sodium bicarbonate as the major chemical substance. Okay, now secondly, sodium bicarbonate is can be used as fire extinguisher, because it can produce carbon dioxide, right, whenever it is heated. So this carbon dioxide would help the fire to be extinguished quickly. Now in the third use, we can say that it is used for the making of baking powder. Baking powder that we used to use in kitchen is mainly prepared by mixing sodium bicarbonate, baking soda with some uh, acid. Okay, when baking powder is nothing but the combination of baking soda, sodium bicarbonate and acid. So this sodium bicarbonate and the acid that we use to mix in baking soda to make baking powder, that actually produces carbon dioxide, and this carbon dioxide actually helps the uh, food items like cakes, pastries to little bit swallow it in to some extent, and they used to swallow it to some extent by the effect of carbon dioxide. Okay, that is obtained by mixing baking soda and H plus or acid. And this carbon dioxide is responsible for the swallowing of that food items, right? Now in case of washing soda, that is another important substance. In case of washing soda, we can say that washing soda, first of all, what is the formula? Na2CO3 10H2O. So it is obtained by heating sodium bicarbonate, as you have already discussed. We have already discussed that sodium bicarbonate is obtained by heating sodium carbonate is obtained by heating sodium bicarbonate, right? And the sodium carbonate, if the sodium carbonate that is formed in the first process is recrystallized, that means if he is to take some water molecule, then it would form the main compound washing soda, Na2CO3 10H2O. Okay, so these water molecules, they are called water of crystallization, that we would discuss later on. Okay, so this water that are present in Na2CO3 are called water of crystallization, and these waters are loosely bound with the salt. This salt is called hydrated salt, that's why. And this hydrated salt, sodium carbonate 10 water, if we heat the salt, then this water molecules will first eliminate from the salt, and it will form Na2CO3 with the liberation of 10 water molecules. Okay, now what is the use of washing soda? Washing soda is used in glass, soap and paper industries mainly. Secondly, it is used for the preparation of some sodium compound like borax. Borax is a compound that is made of sodium, and for the production of borax, we use the sodium carbon. We use this washing soda as a material, right? So these are the texture of baking soda and washing soda. As you can see over here, these are the almost those have these compounds have this have almost the same type of texture, right? Okay. Baking soda, this is baking soda and this is washing soda. Now the third compound, that is called plaster of Paris. It is mainly obtained by heating the gypsum. Gypsum means calcium sulfate to water. By heating the gypsum, we can get a compound that is called calcium sulfate hemihydrate. Okay, CaSO4 half H2O, calcium sulfate hemihydrate, with the liberation of 1.5 moles of water. Okay, so this calcium sulfate hemihydrate, this is called the plaster of Paris. Okay, it is used in many purposes, like in hospitals, in support for in supporting of fractured bones. When we used to suffer from fractured bones, then doctors used to make a plaster around the fractured bone portion, and that is the plaster of Paris. That is the chemical formula is calcium sulfate hemihydrate, that means calcium sulfate half water. Okay, now we will move to the topic water of crystallization. So first of all, what is water of crystallization? Water of crystallizations are the fixed number of water molecules that are present in one formula unit of a salt. In some salt formula, like in the previous slide, as we have discussed, in washing soda, that contains some water of crystallization, 10 water molecules are present in that compound. So in case of water, in case of those salts that contain some water molecules fixed in their formula, these are called water of crystallization. And the salts that contain the water of crystallizations are called hydrated salts. Okay, so these hydrated salts, that what are the common properties of these hydrated salts? Hydrated salt easily lose the water molecules when they are heated in strong heat. Okay, if I give you example like copper sulfate 5 water, this is a hydrated salt that contains 5 water molecules as water of crystallization. FeSO4 7H2O, that is called more salt, and this more salt contains 7 water molecules as water of crystallization. Calcium sulfate 2 water, that is called gypsum, that contains 2 water molecule as water of crystallization. And whenever we heat those hydrated salts, sometimes we observe some color change or some change of particular order whenever we are heating those hydrated salts. Suppose if I take copper sulfate 5 water, and if we heat it, then the blue color of the copper sulfate 5 water would be fade up, or it will be turned into a colorless solution, that is called CuSO4, and the 5 water molecules will be eliminated. Okay, so this is called anhydrous copper sulfate. Anhydrous means without water. So this CuSO4 doesn't contain any water molecules, so this CuSO4 is called anhydrous copper sulfate. Okay, and this anhydrous copper sulfate has no color, while this copper sulfate 5 water has blue color. So whenever we are heating this copper sulfate 5 water, yeah, the color change that we observe is from blue color to colorless. Okay, now we are moving to the next compound, that is the bleaching powder, that is called bleaching powder. It is mainly manufactured from chlorine gas, first of all. Secondly, it is prepared by the action of chlorine on dry slacked lime. Calcium hydroxide is called slacked lime, and if we pass chlorine over it, then we can get CaOCl2 bleaching powder. CaOCl2 with the liberation of water. Okay, CaOCl2 is the formula of bleaching powder. What are the uses? The uses are mainly for bleaching purposes, bleaching of cotton and bleaching of linen materials in textile industries, and it is also used in disinfecting the drinking water. Sometimes we observe that the family members of us used to spread some bleaching powder to disinfect it, to make the disinfectant water that we could drink, right? And this is the texture of the bleaching powder. Okay, it's a white material. Okay, almost crystalline, right? So this is all about some important the most important topics of the chapter 2 of your science part, acid, bases and salts. Thank you for watching this video. See you in the next class. Thank you.